Hi everyone. So I take some little gap. Then let us discuss some problems regarding to this resistance and resistivity. Okay. And in the previous class, while discussing about the resistivity, and I also explained and I also told you already conductivity. So resistivity is the property of a material, to obstruct the flow of electric current, whereas the resistance means measuring how the obstruction takes place, right? So conductivity is also known as the reciprocal of resistivity. So the reciprocal of the resistivity is called conductivity. It is represented with sigma, a symbol called sigma, whereas the resistivity is represented with symbol called rho. Rho is the symbol of resistivity. Sigma is the symbol of conductivity. So sigma or conductivity is equal to 1 by rho. So that means conductivity is equal to 1 by resistivity. Conductivity is equal to 1 by resistivity. So resistivity units 1 by ohm meter. So SI unit of conductivity is Siemens meter. SI unit of conductivity is Siemens by meter. So this is simple thing. SI unit of conductivity is Siemens by meter. Conductivity sigma is equal to 1 by rho, that is 1 by resistivity. Maybe the textbook not given, or if in your school maybe the private science books are used, maybe that include, but that's why I am telling you. So one of the important one, conductivity. Now let us solve some problems regarding to resistivity problems. See, electricity chapter, mostly every topic has problems, and then previously we solved problems regarding to Ohm's law. Then now problems on resistivity. So now let us solve some problems. So you have to practice the problems. How many problems you have in your textbook? So you must be practice. So it is very useful to you. Then understanding the concepts is very easy. If you read your textbook 3 times or 4 times, you are able to understand very easily, and the topic if you listen the class attentively, also easy to understand, but application is difficult. So application is a very very important thing. So please apply the concept while solving the problems, the very very important thing, right? So these are okay, then the Ohm's law problems okay, then how much of electric current is passed through a conductor is okay, potential difference is okay, resistance also okay, but we have some problems in this chapter is circuit diagrams. Based on the circuit diagrams, many problems are there, so they are very very difficult, but there is some tricks are there, some tips are there. So these tips are explained by your teacher, and here also I will explain a simple tips are the tricks for how to solve the problems regarding to circuit diagrams. Circuit diagrams, okay. Then later we will discuss. Now let us solve first problem. A copper wire of length, a copper wire of a length, a copper wire of length 2 meter and area of cross section, area of cross section 1.7 into 10 power minus 6 meters square, 10 power minus 6 meters square, has the resistance of of 2 into 10 power minus 2 ohms, 2 into 10 power minus 2 ohms. Calculate the resistivity. Calculate the resistivity of copper. Calculate the resistivity of copper. This is the formula. So in the problem given, length of the wire, area of cross section, and resistance of copper. So let us solve the problem. Have to practice the problems. First of all, let us write the given values. Given resistance R is equal to 2 into 10 power minus 2 ohms. Then length L is equal to 2 meters. Then area of cross section. Then area of cross section A is equal to 1.7 into 10 power minus 6 meters. Then what we need to find? Resistivity. Resistivity rho is equal to. So read the problem at least twice or thrice. Let's understand the given values. Then use the correct formula. To use the correct formula, please read the problem at least twice or thrice. So as we know, resistivity rho is equal to RA by L. Substitute R values 2 So here what we have resisted side only we have to write the units also ohms into meter square by meter square by meter square. Let us take simple calculation. 2 to get cancelled here. The remaining what we have 1.7 into 10 power minus 6 into 10 power minus 2. 1.7 into 10 power minus 2, 10 power minus 6. So this should be right as 1.7 into 10 power minus 8, 6 plus 2. So in exponents, you know, if the bases are equal, then the exponents are also we should add with the powers. When the bases are equal, then we should add the powers. So finally we get 1.7 into 10 power minus 8. So here square meter and square cancel. Remaining we have ohm meter. So resistivity of copper is equal to 1.7 into 10 power minus 8 ohm meter. 1.78 10 power minus 8 meter. So in this problem we calculated the resistivity of copper. So such type of problems are very easy because of we use the formula directly. Then the simplification a little bit confusion. So make it the simplification very simple by thinking. So instead of doing wrong, right? So let us check the powers are minus values or plus values. So like that, whenever you check all the given values, so the simplification is our wish. Whatever the method you have to use to simplify simplify, but the answer must be same. You should not change the answer. So this is the simple problem and very easiest problem. Then easy to solve. But if the problem is twisted, then we have to understand the concepts. Let us discuss one more problem. So second problem. Sorry for this. Second problem. Let us discuss. A copper wire has a diameter. A copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 power minus 8 ohm meter. 10 power minus 8 ohm meter. So let's calculate what will be the length. What will be the length? What will be the length? What will be the length of this wire? What will be the length of this while to make its resistance, to make its resistance 10 ohm, then how much does the resistance change if the diameter is doubled. So now understand the problem. For understanding, read the problem twice or thrice. The problem is given as a copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 power minus 8 ohm meter. So what we need to find here? What will be the length of this wire to make its resistance 10 ohms, and how much does the resistance change if the diameter is doubled? So we need to find the length of the wire. If we know diameter only, so we need to find the length of the wire to make its resistance 10 ohm as well. If we change the diameter, if this diameter 0.5 mm is double, then what about the resistance of the copper wire? So we need to find the length of the copper wire and need to find the resistance of the copper wire if diameter is doubled. So this problem has two parts. Let us understand and try to solve the problem. Okay. First of all, we need to calculate the area of cross section. Of the copper wire. Because in this problem is not given any cross section area. If the cross section area A is given, then very easy to solve. So as we discussed previously, resistance of the conducting wire is inversely proportional to the area of cross section. That means R is proportional to 1 by A, and also we know R is proportional to length. Resistance of the conducting wire or the wire is directly proportional to the length, inversely proportional to the area of cross section. But in this problem there is no area of cross section, so we need to calculate the area of cross section first, after we calculated the length. So first of all we need to calculate the area of cross section. So diameter, solution, first of all write the given diameter, maybe visible or not with the blue, not visible properly. So diameter of wire is equal to 0.5 mm. 0.5 mm. So diameter, then it is to be half of double of radius. Diameter is the double of radius. So its radius r will be. So first of all, find the radius. Radius of a wire r is equal to d by 2. For example, d by 2. That is equal to 0.5 by 2. 0.5 by 2. Then how much you get approximately? So 5 by 20 you can write as 5 by 2, 5 by 20. So 0. Diameter or the radius is equal to 0.25. 0.25 millimeter. So radius is r is equal to 0.25 millimeter. So now calculate the area of cross section. Area of cross section. A is equal to, so spherical circular will be equal. Thus the radius of copper is, now cross section of the wire 5r square circular. So this 0.025 meter should be written as 0.25 by 0.25 by 1000 meters. 0.25 by 1000 meters. Convert millimeters, convert into 1000. No, sorry, 1000 into meters. So this again should write that is equal to 0.25 into. So this written as 0.25 by 10 power 3 meters. This 10 power 2 you can write as 10 power minus 3 meters. So radius. So diameter given, they have to be calculated to find the radius. So 0.25 into 10 power minus 3 meters. So cross section area A is equal to 5r square. Cross section area A is equal to 5r square. So substitute the values now. That's equal to 22 by 7. That's equal to 22 by 7. That is equal to 22 by 7 into 0.25 into 10 power minus 3 square. So you can write as 0.25 into 10 power minus 3. So r square it will be write as r is equal to 0.25 into 10 power minus 3 meter. So r square is 0.25 into 10 power minus 3 and 0.25 to 10 power minus 3. So after all the simplification, so we get the area of cross section A is equal to how much? 0.1964. 0.1964 into 10 power minus 6. 10 power minus 6 meters. So it is simplification will get 10 power minus 10 power minus 10 power minus 6. 0.25. So that should be right as 22 by 7 into 25 by 100 into 25 by 100. The matter like this. So get 25 1 by 4 or 1 by 4. 22 by 7 into 1 by 16. 1 by 16. So 22 by, so this simplification happened. So 2 8 jar, 2 11 jar. So then simplification 11 by 8 7 jar. 7 jar 56. 56. Whenever divide the 56, not multiple, there is 0 to get right. So 56 1 jar 56 4 10 into 5 10 at 0 again. So 10 under 560, then we can write 9. So 56 into 9, 9 6 are 54, 9 6 are 9 5 are 45, 49. So 494, 6 is so 13 minus 9, 4 again, we can write 0. So then later we can simplify it to get 0.1964. 0.1964. So as I told you, our simplification is our lesson. So which one is easy, then you can do that method, right? So 10 power 10 power minus 6 are this 0.25 written as 25 by 100 and 25 by 100. So 25 1 jar, 25 4 jar, 1 by 4, 1 by 4 happened. So 22 by 7 1 by 16. Multiply with 2, 11, 8. So 11 by 56. Then divide. So we get 0.19 something. Then power minus 6 already. So area of cross section is we calculate. Then now what we have to do? What is the length? What is the length of a copper wire to make its resistance 10 ohms? To make its resistance 10 ohms. So coming to the first part, we can write resistivity. Rho is equal to 1.6 into 10 power minus 8 ohm meter. 1.6 into 10 power minus 8 ohm meter. So according to the problem, resistance R is equal to 10 ohms. So according to the problem, resistance R is equal to 10 ohms. Then what we need to find? Length L is equal to, and also we know area of cross section. Area of cross section A is equal to 0.1964 into 10 power minus 6 meters. So as we know, R is equal to rho A by L. So from this you can write length L is equal to you can write rho A by R. Length is equal to rho A by R. Then substitute the R values. Rho is equal to 1.6 into 10 power minus 8 into area of cross section 0.1964 into 10 power minus 6 by resistance 10. So all simplification, by doing the all simplification we get length of the copper wire is equal to 122.7 meters. 122.7 meters. We'll simplify it right. So then now sorry, some mistake. Here the mistake is rho A by L. R is equal to rho A by L. So from this we can write rho is equal to R L by A. Right. L is equal to rho A by R. Rho A by R. That is equal to so resistivity R is rho is equal to, so from the formula rho is equal to RA by L. Sorry, R is equal to actually E by I. E by I. Sorry, the formula rho is equal to RA by L. So from this we can write L is equal to RA by rho. L is equal to RA by rho. That is equal to R now 10. A is 0.1964 into 10 power minus 6 by resistivity 1.6 into 10 power minus 8. 1. So after then we can do small simplification. 10 into 0.1964 into 10 power minus 6. We should write this 10 power minus 8 into the numerator. It becomes 10 power 8 by 1.6. 1.6. So that's equal to 10 into 0.1964 into 8 minus 6. So 10 square by 1.6. So then it becomes 10 cube. 10 cube, that is equal to 10 into 0.1964 into 10 square. This is written as 16 by 10. Then again we can write 10 into 0.1964 into 10 power 2 into 10 by 60. By 60. So 10 into, substitute the values and simplify it. So 0.1964 into 10 square, 10 square, 10 square, 10 square, again 10 power 4 will come. So we can write 0.1964 into 10 power 4, because 10 power 1 to 10 power 1. 10 square become, all the 10 square will have, so 10 power 4 by 60. That is equal to, it is 10 power, when multiply with this 10 power 4 and then we can get 1964 by 60. 1964, so after we can write, so maybe 122.7 meters. So the length of the copper wire is, the length of the copper wire is 122.7 meters to make its resistance 10 ohms. To make its resistance 10 ohms. So like this, you have to practice. That's why the formula is very, very important. Applying the concept is very, very important. Even I also get some confusion by writing the formula. After simplification, we get the length L is equal to 122.7 meters. 122.7 meters. So the length of the copper wire required. The length of the copper wire required. So finally, the length of the copper wire, the length of the copper wire required to make its resistance to make its resistance 10 ohm is 122.7 meters. 122.7 meters. So you can calculate it how much of length is required. How much of length is required to make the resistance of copper wire to 10 ohms or omega is 122.7. So we completed only the first part. Then coming to the second part of the problem. This is the first part. Then coming to the second part of the problem. B. How much does the resistance change if the diameter is doubled? If the diameter is doubled. So the resistance of wire is inversely proportional. The resistance of the wire is inversely proportional. As we know, the resistance of the wire is inversely proportional to the square of diameter. So when the diameter of the wire is doubled, if the diameter of wire is doubled, so what is the diameter? 0.5. That is made into two times. Then the resistance will be 1/4. So 1 mm double is 0.5 into 2, that is equal to 1 mm. 1 mm. So 0.5 we can write as 1/2. We can write as 1/2 millimeter. Then square of, you can write square. So 1/2 whole square. Then we can write 1/4. So the resistance of a wire is inversely proportional. To the square of diameter. So when diameter is doubled, the resistance is 1/4. The resistance is 1/4. The resistance will 1/4. So this way, apply the concept into the problem. So take much time to explain. So let us take the one more problem regarding to this resistivity. So I hope understood. So if you not understood, watch my video again and again. Respect the simplification. Especially the simplification. Simplification is your visual problem. Then the next problem, a 6 ohm resistance, wire is doubled doubled up by folding. Calculate the new resistance. Calculate the new resistance of the wire. So the problem is given a 6 ohm resistance wire is doubled up. Doubled up and what will happen? Thickness increases. So what will happen next? Its resistance will increase or decrease, and we have to find out. Double up, calculate the new resistance of the wire. The thickness is doubled. So what will happen? The thickness is doubled, resistivity decreases. Let us solve the problem. Suppose if the length of the wire taken as L and area of cross section is A, then resistivity is equal to, in the problem, assume that if the length of a wire is equal to L, area of cross section is A, then resistivity is equal to rho. As we know, resistivity rho is equal to RA by L. Resistivity is rho is equal to RA by L. From this, you can write R is equal to rho L by A. R is equal to rho L by A. So, on the problem given resistance, if resistance R is equal to 6 ohms, resistance R is equal to 6 ohms, to substitute the value. 6 is equal to rho L by A. 6 is equal to rho L by A. Or now, when this wire is doubled up by folding, then its length become half. That length will become half if the wire is doubled. The wire is doubled, then the length become half. That is 1 by 2. That is 1 by 2. It is 1. But on folding, for the doubling the wire by folding, its area of cross section will become double. That is, area of cross section will become 2A. By folding, the area of cross section, become double. That is 2A. So when we folding it, so what will happen here? Length decreases, area of cross section increases. Length increases, area of cross section is decreases. Right. So just like imagine that this is a length. If it is folding, length become half. Then what about the area of cross section? Become double. Become double. And then what about the resistance? What about the resistance? So it is a wire of 6 ohms resistance is doubled by folding it. So when doubled by folding, length decreases to half, area of cross section become double 2a. Become double 2a. So L is equal to 1 by 2. L is equal to 1 by 2. Means you can write as L by 2. Then length is equal to L by 2. Area of cross section. Area of cross section A is equal to 2A. L is equal to L by 2. Now substitute these two in the equation 1. For example, substitute L and A in equation 2. Substitute now, then we can write R is equal to rho is common, then L become L by 2 by A become 2A. That is equal to rho into L by 2 into 2A. 2 into 2A. So then resistance. Resistance you can write R is equal to R by 6. According to the problem, so the new resistance of the double up wire is R. So R is equal to rho into L by 2 into 2A. That is equal to rho into L by 4. 2 2 are 4 into A. So R is equal to, this should be written as 1 by 4 into rho L by A. This rho L by A is equal to 6. So new resistance R is equal to rho into L by 2 into 2A. Just I submitted L and A value here. After folding, this is after folding or after doubling. After doubling, length become L by 2, area of cross section become 2A. So this length and area of cross section substituted here to find the new resistance. So R is equal to rho into L by 2. So L become L by 2, A become 2A. So after simplification we can write R is equal to 1 by 4 into rho L by 2. So from this new resistance R is equal to 1 by 4 into, already we know this 6. R rho L by A is equal to R into 6. Can write R is equal to 6 by 4. Divide by 4, 6, 1, 4 jar 1, 2.0, 4, 5 are 20. So new resistance R is equal to 1.5 ohms. 1.5 ohms. So in this way we need to apply the formula. So read the problem. Before folding we assuming that. So for example, here consider this is this part is completely before doubling. From this part, this complete part is taken as after doubling. So before doubling, length is L, area of cross section A, resistivity rho. According to the problem, resistance given 6 ohm. So after doubling, if the wire is doubled, the length become half. Then area of cross section become double. So these values should be submitted in the equation 1. So R is equal to rho as usual. Then L become L by 2. Cross section become 2A. Substituted A. So R into L by 2 into 2A. So this is can write, for example, new resistance. New resistance R is equal to RL by 2A, ROL by 4A. So 2 into 2, 4 jar, ROL by A. This should be write as like this, 1 by 4 into ROL by A. According to equation 2 1. So here we can write 6 from this rho L by A. So get substituted and simplified. We get the new resistance is 1.5 omega or ohms. So here the resistance is reduced. So then the new resistance of the double up wire is 1.5 ohms. So in this way you have to practice the problems without seeing your answer. By practicing it will come. Understand the problem by reading the problem twice or thrice. Then it is very easy to understand and use the correct formulas. So thank you so much. So that's all for today. Then later I come up with a new concept. Thank you so much, and subscribe if you did not subscribe my channel. Inform your friends to subscribe. Ask them to watch my videos and watch my videos accordingly the topics which is going in your school. Signing off. So this is the complete problem. So two parts, before doubling, after doubling. So before doubling length, after doubling length, area of cross section. Right? Sorry for inconvenience. Before doubling, this complete part is after doubling. After doubling length L by 2, area 2A. Substituting all these values, we get the new resistance R is equal to 1.5 ohms. So understand the problem. So next class we will discuss some more problems. The time is there. So thank you so much.